Hello, Dan Adolski here from howtomechatronics.com. In this Arduino tutorial, we will learn how to configure and pair two HC05 Bluetooth modules as a master and slave devices. In my previous two tutorials, we already learned how to connect the HC05 Bluetooth module to the Arduino and make a communication between an Android smartphone and the Arduino. In those tutorials, we use the HC05 Bluetooth module with its default configuration as a slave device. However, now for this tutorial, we need to configure both modules. In order to do that, we need to switch to AT command mode, and here's how we will do that. First, we need to connect the Bluetooth module to the Arduino as the circuit schematic explained in the previous tutorials. What we need to do additionally is to connect the EN pin of the Bluetooth module to the 5 volts and also switch the TX and RX pins at the Arduino. So the RX pin of the Arduino needs to be connected to the RX pin of the Bluetooth module through the voltage divider, and the TX pin of the Arduino to the TX pin of the Bluetooth module. Now, while holding the small button over the EN pin, we need to power the module, and that's how we will enter the command mode. If the Bluetooth module LED is flashing every 2 seconds, that means that we have successfully entered the AT command mode. After this, we need to upload an empty sketch to the Arduino, but don't forget to disconnect the RX and TX lines while uploading. Then we need to run the serial monitor and there select both new line and carriage return, as well as 38400 baud rate, which is the default baud rate of the Bluetooth module. Now we are ready to send commands, and their format is as following. All commands starts with the AT followed by the plus sign, then a parameter name, and they end either with the question mark sign, which returns the current value of the parameter, or the equal sign when we want to enter a new value for the parameter. So, for example, if we type just AT, which is a test command, we should get back the message OK. Then if we type AT plus UART question mark, we should get back the message that shows the default baud rate, which is 38400. Then if we type AT plus roll question mark, we will get back a message roll equals 0, which means that the Bluetooth module is in slave mode. If we type AT plus ADDR question mark, we will get back the address of the Bluetooth module, and it should look something like this. Now we need to write down this address as we will need it when configuring the master device. Actually, that's all we need when configuring the slave device to get its address, although we can change many different parameters like its name, baud rate, pairing password and so on, but we won't do that for this example. Okay, now let's move and configure the other Bluetooth module as a master device. First, we will check the baud rate to make sure it's the same 38400 as the slave device. Then by typing ATRoll equals 1, we will set the Bluetooth module as a master device. After this, using the AT plus C mode equals 0, we will set the connect mode to fixed address, and using the AT plus bind equal command, we will set the address of the slave device that we previously wrote down. Note here that when writing the address, we need to use commas instead of colons. Also note that we could have skipped the previous step if we entered 1 instead of 0 at the AT plus C mode command, which makes the master to connect to any device in its transmission range, but in that case we would have less secure configuration. For more details and a complete list of commands and parameters, visit my official website article. Nevertheless, that's all we need for a basic configuration of the Bluetooth modules to work as a master and slave devices, and now if we reconnect them in normal data mode and repower the modules, in a matter of seconds the master will connect to the slave device. Both modules will start flashing every 2 seconds, indicating a successful connection. Okay, so now we are ready to make the practical example for this tutorial. Here's the circuit schematic. We will use a potentiometer at the master to control a servo motor at the slave, and vice versa. We will use a push button at the slave to control a LED at the master. Here are the Arduino codes. So first we need to define the pins and some variables needed for the program. In the setup section at the master, we set the LED pin as output and set it low right away, as well as start the serial communication at 38,400 baud rate. Similar at the slave, we set the button pin as an input and define the servo to which pin is connected and start the serial communication with the same baud rate. In the loop section, in both codes, with the serial.available function, we will check whether there is available data in the serial port to be read, and using the serial.read function, we will read and store the data into the state variable. So, if the master received the character 1, which is sent from the slave when the button state is high or when the button is pressed, the LED will be on. Else, if the character is 0, the LED will be off. As for the servo motor control, first at the master we read the potentiometer value and map it into a suitable range for the servo from 0 to 255. This value is sent to the slave, which uses it to rotate the servo motor accordingly. Thanks for watching, and for more